Good morning, everyone, and welcome to the next Sensor Basic TPMS training. My name is Kaizen Chin, and I'll be guiding you through today's session. Whether you're new to TPMS or just need a solid technical refresher, this training is designed to give you clear, actionable knowledge that helps you not only understand the system, but diagnose, install, and program sensors with confidence. This is a fundamental focus course, perfect for entry level technicians, support staff, and anyone involved in the tire pressure monitoring process. Let's dive in and build that strong foundation. Understanding TPMS is an essential step for every first time user. First, it improves operational efficiency. A properly trained technician can install, program, and troubleshoot sensors faster, reducing service delays and minimizing customer wait times. Second, it helps prevent costly mistakes. When users understand how TPMS works, they are far less likely to misconfigure, damage, or improperly install the system. Third, good training supports long term reliability. It ensures that TPMS systems deliver accurate diagnostics and maintain consistent performance. The more a user understands TPMS, the smoother the communication becomes between the service team and Next sensors, building trust and delivering better results. To ensure TPMS functions properly, we must first understand its basic logic and terminology. Sensor type, frequency, and communication protocols vary between vehicles. Choosing the correct settings is critical. Selecting the wrong option may cause relearn failures, sensor miscommunication, or false alerts. So, having this foundational knowledge isn't just theory, it's the key to efficient, accurate TPMS service. When dealing with TPMS equipped vehicles, it's critical to identify if the system is highline or lowline. A highline system offers a practical advantage. Technicians can quickly identify which tire has a low pressure issue just by looking at the dashboard. No scan tool required. Most highline systems support auto location, which is the ability to detect changes in tire positions. For example, if tires are rotated without reprogramming the IDs, the vehicle will automatically detect the new positions and remap the sensor IDs in the ECU. This is not the same as auto relearn, which refers to learning new sensor IDs after a replacement. Auto location only corrects existing ID positions, not new sensor recognition. While highline systems offer more features, they tend to consume more battery due to ongoing communication. On the other hand, low-line systems display only a general TPMS warning light, no pressure, no position info. Always confirm the system type before starting diagnostics or programming. TPMS systems are either direct or indirect. Direct TPMS uses entire sensors for real time pressure readings, highly accurate and responsive. Indirect TPMS estimates pressure using the ABS system. It's less accurate and slower to detect leaks or pressure loss. Our app supports direct TPMS only to ensure reliable programming and diagnostics. TPMS sensors operate using two key frequencies. A 125 kHz low frequency LF signal is used to wake up the sensor. The sensor then responds with a 315 or 433 MHz high frequency signal depending on the vehicle. Some vehicles have built-in LF initiators for auto relearn or auto location, but most do not support triggering while stationary. That's why using a professional TPMS tool is highly recommended for reliable sensor activation and faster diagnostics. Beyond frequency, TPMS sensors must use the correct signal protocol to communicate with a vehicle's ECU. Different makes, models, and production years often require unique communication formats, even if the frequency is the same. That means a 315 MHz sensor won't work if the protocol doesn't match. When programming or selecting a sensor, always refer to the exact vehicle specification to ensure protocol compatibility. Two key pieces of information are critical when setting up TPMS sensors. First is the vehicle identification number, VIN, especially the 10th digit, which identifies the model year and helps avoid protocol or frequency mismatches. Second is the OEM standard tire pressure, which defines the baseline for low pressure warnings. In most cases, the warning threshold is set 6 to 8 psi below the standard. If the TPMS light is on but all TPMS is able to trigger, you'll need to inflate the tire back to at least the standard pressure to clear the warning. Next, we walk through the standard TPMS service workflow. This includes verifying vehicle specs, checking sensor status, programming or cloning sensors, installing them, and completing the relearn process. Each step builds on the last, so understanding the full flow is key to successful TPMS work. Let's break it down step by step. Let's go through the next TPMS workflow. Step 1. Select the correct make, model, and year. This ensures compatibility. Step 2. Diagnose the issue. Is the sensor missing? Has a dead battery? Or does the tire just need inflation? Sometimes it's not the sensor, just low pressure. Step 3. Program a new sensor or clone the existing one. If you choose to clone the original sensor ID, you can skip step 5. No relearn needed. Step 4. Install the sensor into the tire. Step 5. If you programmed a new ID, perform the relearn procedure. OBD, manual, or auto depending on the vehicle. When this
setting
process
up
ensures accuracy,
TPMS sensors,
saves time,
the
and
first
avoids
and most
unnecessary
important
replacements.
step is picking the right car model and year. One easy way is to look at the 10th digit of the VIN. It tells you the model year. But here's the catch. That same year might have different versions. For example, BMW's 2 Series could be a 2-door or 4-door, and the 5 or 6 Series might include a GT model. If you choose the wrong one, the sensor won't pair right and everything falls apart. So, double check the details and make sure you've got the exact match before moving forward. Some cars in the same model year might use different TPMS sensor frequencies like 315 or 433 MHz. That means checking just the year isn't enough. You need to confirm which frequency the vehicle actually supports. One of the best ways to do that is by looking at the OE sensor itself.
Most OE sensors will show the frequency printed right on them. For example, part number 42607-0C080 clearly shows 315 MHz. If the old sensor still has battery, you can trigger it and check the response. You can also use a key fob frequency detector to help identify the correct type. And if the car supports manual relearn, try pairing both options to see which works. Bottom line, pick the wrong frequency and the whole TPMS system fails. For some vehicles, you can't rely on just the model year to select the right TPMS sensor. You might need to look at the production date, trim level, or even which manufacturer made the sensor. It's common to find same year, same model cars that use completely different frequencies and protocols. So don't just go by the year, get the full details. Choose the correct TPMS option so the vehicle can actually receive the signal. Place the sensor in position. Then hold the programming pad directly above it, aligned with the lead zone. Keep any unrelated sensors at least 2 meters away to prevent accidental programming or signal interference. If you are creating a new ID, go with the auto-generate option. And if one of the OE sensors is dead, the others probably aren't far behind. Swapping all four at once is highly recommended. Now we proceed with replacing and installing the TPMS sensor. After the sensor has been successfully programmed, begin by removing the old TPMS unit from the valve stem. Install the new sensor carefully onto the valve stem. If using a rubber valve, apply a small amount of lubricant to assist the installation and prevent damage. Once secured, remove any excess lubricant to avoid future rotation or slippage of the valve. Finally, adjust the tire pressure of each wheel based on the manufacturer's recommended pressure values, ensuring accurate readings and safe operation. Let's move on to the TPMS relearn procedure. Each TPMS sensor carries a unique ID and communication protocol. When sensors are replaced, the vehicle must relearn their IDs using one of several supported modes. Depending on the make and year, your vehicle may offer multiple relearn options. OBD relearn, used in most Asian vehicles and some US models, uploading IDs through an OBD interface. Manual relearn, available on select American vehicles via factory-defined steps. Auto relearn, common on European vehicles and some US models, where the ECU detects sensors during driving. With sensor ID cloning, relearn can sometimes be skipped entirely. Reminder: some vehicles support more than one relearn method. Always verify and select the correct approach based on your car's specifications. In this section, we'll explain the TPMS OBD relearn procedure. This method is commonly used on Asian vehicles and some US models. It works by uploading new sensor IDs directly into the car's ECU through the OBD port. So what does the process look like? First, you'll use a TPMS tool to activate each sensor and capture its ID. Next, switch the ignition to the on position and make sure your battery has enough charge, ideally above 12.4 volts. Then, connect the OBD2 cable and send those IDs into the system. Once the upload is complete, wait for the confirmation message. That means your relearn is successful. And in some cars, you might take a short drive afterward to verify the pressure readings are showing up properly. This section explains the TPMS manual relearn process. It's mainly used for American-made vehicles. The general flow looks like this.
First, follow the manufacturer's steps to enter relearn mode, so the vehicle is ready to receive the new sensor IDs. Then, use a TPMS tool to activate each sensor one by one. The typical sequence is left front, right rear, then left rear. Once finished, the vehicle will confirm success with a beep, flashing lights, or a dashboard message. After that, you exit the relearn mode and the system starts reading tire pressure data correctly. Don't forget, the way you enter relearn mode can vary by vehicle, so always refer to the owner's manual for exact steps. In this section, we'll go over the auto relearn process for TPMS. Before driving, most vehicles recommend staying parked for around 20 minutes. This allows the ECU to reset and prepare for detecting new sensor IDs. This method is common on European vehicles and some American models and doesn't require a scan tool. First, install the new sensors onto the wheels. Then, drive the vehicle at speeds above 30 miles per hour for roughly 10 to 20 minutes. During that time, the ECU will automatically detect and register the new sensor IDs. Once everything's paired, the TPMS warning light will turn off and tire pressure readings will appear correctly. This slide explains the trigger order for TPMS sensors. Most vehicles use a standard sequence when activating or relearning sensors. Left front, right rear, left rear. Following this order helps the system identify each wheel's location correctly. But if the vehicle has dual rear wheels, like on some trucks, the sequence might be different. Always follow the instructions provided in the app or check the owner's manual to avoid mispairing or incorrect readings. Let's go over TPMS sensor ID cloning. When the new sensor properly duplicates the original ID and is installed in the same position, most vehicles won't need a relearn or reset. Just make sure the format is correct, either hex or decimal. Hex IDs use numbers 0 to 9 and letters A to F, while decimal uses only numbers. Using the wrong format might cause the vehicle to reject the sensor. There are a few cloning methods. If the original sensor still has battery power, you can clone using the activate mode. If your app supports OBD, you can extract the ID from the ECU. If the original sensor is dead, but you're using an OE, original equipment sensor, you can manually enter the ID to clone it. Keep in mind, manual clone only works with OE sensors. Aftermarket ones aren't supported for this method. Using the right approach saves time and prevents setup errors. That wraps up our basic TPMS training. From sensor selection and ID programming to installation and relearn procedures, each step matters. Following the right workflow helps reduce mistakes, improves efficiency, and makes TPMS service smoother for everyone. Thanks again for joining us. If you'd like to explore advanced features, special vehicle setups, or troubleshooting tips, we're here to help and keep you updated.